Okay, so we've done the paired t-test. Now we're going to do the non-parametric equivalent called a Wilcoxon-Sign-Rank test. To do that, we're going to go back to SPSS. We're going to confirm that our data is still split. So we want to organize outputs by groups, put in our group, hit OK. Now we're going to analyze and run our Wilcoxon-Sign-Rank test. If you go down here to non-parametric test, you'll see one sample, independent sample, related sample, and legacy dialog. So what the legacy dialog allows you to do is to have a little bit more control. These other tests can be run and you can have customize analysis, identify the fields that you want to put in or the labels, and then do different tests. I guess as much as anything, I'm used to the legacy dialog because that's how I originally learned it. For your homework, you can do it either way you want. Maybe even try it both ways and see which one you like better. I'm going to run the data using the legacy dialog. So I go down to non-parametric legacy. And again, I have two related samples. So again, it's a pre-post analysis of healthy and a pre-post of the injured. Okay, so you can see I've already put this in. I ran it once before to make sure everything worked correctly. Here's my pre and my post upper trapezius average strength data. It automatically defaults to Wilcoxon. There's other tests that can be run. Each one has different pros and cons. You can ask the statistician when it's appropriate to use one over another. I'm going to check the options if I want descriptive or quartiles. Now, if I have non-parametric data, I mentioned before, if you have parametric data, you often report means and standard deviations. If you have non-parametric data, you often want to report medians and interquartile range. So since this is a non-parametric analysis, I'm going to ask it to give me quartile information so that as I'm reporting my results, I might want to use my mean and interquartile range to explain that difference. Hit OK, and voila. So now what you see in the healthy is their strength at their beginning was 17.95, increased a little, not much. This is the 25th and 75th percentile. So this is our means or median values, I should say. This is our interquartile range. We ran the Wilcoxon-Sign-Rank test. And again, asymptotic significance is basically the same value as what we saw with the parametric. It was about a 0.9. So if I'm going to run the non-parametric data, copy, bring that over to my pre-test, post-test upper trap. This is now going to be my non-parametric analysis. Remember, for your homework, you don't have to do both. I'm just showing you how to do both in this sample video. There's my descriptive statistics for my pre and post, and the significance value is in the result window. This is my test significance. Copy and paste. So you can sort of see that both analyses resulted in very similar results as you went through that. Okay, so now let me go check my injured. So go back to my output. So here's my injured group, group injured. Here's my descriptive statistics. They went from 12 to 22 on average, or based on the median score. That's a pretty nice jump. in strength. So this is my injured. This was my healthy. Come on. There we go. Paste. There's my median values. These are my interquartile ranges. And my expectation is based on that large a change, I expect to see a significant, and voila, a significant. So this Z-score is basically the test from the Wilcoxon-Sign-Rank, and then the asymptotic significance is again at 0.008. So I can explain more in class what they're actually doing with non-parametric data if you're interested, but basically instead of using the actual values, because the data is not normally distributed, it rank orders the lowest to the highest value, and it compares the mean ranks. So you can see here that in the injured group, the positive ranks were all higher in the post-op or post intervention compared to the pre. So that's a little bit of a quick explanation of how that ranked summary works, but I can explain that more in class. Alright, let me go over here and paste this. And again, the interpretation would be basically the same, right? That we saw a significant difference with our injured but not our healthy. And maybe you would write up your interpretation a little bit different. You could add in the mean or the median values, so you could state something if we went down in here and wrote our interpretation that the injured group demonstrated a significant increase in strength from baseline or pre-measures. And so now if I wanted to use my medians, I might say median slash interquartile range. And maybe I'll just do it this way. So that'll sit in the sentence structure. You could use IQR for that information. So in this case, at baseline, we started at 12.5. with an interquartile range of 11.4 to 18.1. So the injury group demonstrated a significant strength from baseline to post-intervention. And now I'm going to give the post-intervention of 22. Forgot my units, sorry. So this would be in pounds. And the interquartile range is 15 to 24.8. So 15.1, comma, 24.8 pounds. And then I can put my p-value, right? P equals 0.008. No significant increase in strength was observed in the healthy group. And you could add the information like I did, or you could just simply say P equals 0.9. I think it was 9. Oh, too far up. That's healthy. 0.925, 9.93. And that's what I'm looking for an interpretation. Okay, stop there and then we'll do the ANOVA.